Tutorial number 6, question number 1. The slider of mass is equal to 0.4 kilograms moves along the smooth spot surface with velocity of 5 meters per second when in the position shown. It moves along the inclined face of an initially stationary block of M2. We need to determine the velocity v hash of the system after the sliders has come to the rest relative to the block. Apparently, there are 3 stages. Here's our stage number 1. At stage number 2, we have the slider have a velocity of v. And our stage number 3, the slider is at rest relatively to the block. So the system have a velocity of v hash. So from 1 to 2, because there's no friction, so we could say the energy is conservative. So T1 plus V1 is equal to T2 plus V2. T1 is equal to 1 over 2 M1 V1 square. And V1, we set this is our reference. So V1 is equal to 0. T1 is equal to 1 over 2 V square plus M1 G H. So we can cross out the M1 right here. So we have V square is equal to V1 square minus 2GH equal to 5 square minus 2, 9.81 times 0.5, which is equal to, V is equal to 0.9 meter per second. Then from 2 to 3, we saw here's a friction right here. The energy is not conservative, but the linear momentum in x direction is conservative. So we said this is x, this is our y, because linear momentum is not dependent on any internal motion or rotations. So we would say 0.4 times 3.9 times cosine 20 degrees is equal to 2 plus 0.4 v hash. Here's our velocity in x direction. So here is the mass of a whole system, M1 plus M2. So we'll say V hash is equal to 0.61 meter per square. Question number 2. A spring has an initial length of 0.4 meters and it has a relaxed length of 2.5 meters. So the energy of this whole system comes from the elastic potential energy of the spring. So what is the initial potential energy of the spring? It will be Vs is equal to 1 over 2 K delta L square to 1 over 2 30 times 2.5 minus 0.4 square, which is equal to 66.15 joule. Question B, what will be the initial acceleration of the box? If you take a free body diagram of the box, we will say the F comes from the spring. So we'll say Fx is equal to MAX. So it's a K delta L is equal to MBAB. So AB is equal to K delta L MB. K is equal to 30 times 2.5 minus 0.4 over 20, which is equal to 3.15 meter per second square. Question number 3. What will be the speed of the create when the spring reaches a length of 1.5 meters. So we should draw a diagram. When the spring is released, the block will have a velocity to the right, we call this VB, and the crate have a velocity to the left, which is VC. The energy is conserved during this problem, so T1 plus V1 is equal to T2 plus V2. T1 is equal to 0, V1 is equal to 1 over 2 K delta L square, and T1 is equal to 1 over 2 mb VB square plus 1 over 2 mc VC square plus 1 over 2 K delta L square. We call this 2. We call this 1. So it will be 1 over 2, 30 times 2.5 minus 0.4 square is equal to 1 over 2, 20 VB square minus 1 over 2 times 50 as VC square plus 1 over 2 times 30 times 2.5 minus 1.5 square. So 2VB square minus 5VC square is equal to 10.23. Because the linear momentum is also conserved, so M1V1 is equal to M2V2. Let's say 0.0 is equal to MB/VB minus MC/VC. So 2VB is equal to 5VC. Here's our equation number 1. Here's our equation number 2. So we can get VC is equal to 0.76 meter per square. Question number 3. A particle moves on the inside surface of a smooth shell and is given an initial velocity VO tangent to the horizontal rim of the surface at A. We need to determine the magnitude of the velocity at B as well as the angle theta. Because there is no external momentum to input the system, we will say HA is equal to HB. The angular momentum is conservative. So it's MVO RO is equal to MVRB cosine theta. If we take cross section of the shell, we will say here's A, here's H minus A, here's RB, here's RO. So RB over RO is equal to H minus A over H. So RB is equal to RO minus ROZ over H. So we put into the equation, we will get MV RO minus ROZH cosine theta, which is equal to MVO RO. Because there's no friction on the shell, so we will say the energy is also conserved. So TA plus VA is equal to TB plus VB. If we take this is our reference, so for the gravitational potential energy at point A is equal to 0. So we have 1 over 2 mVO square is equal to 1 over 2 mv square minus mgz. So V is equal to square root VO square plus 2gz. So here is our magnitude of the velocity. For the theta, we just put it into the equation. So we will get our cosine theta. The theta will be this equation.